which has to be printed on a earth terminal of an equipment. Say for example, you have a sensitive electronic equipment, the clean earth is printed. So the meaning of this particular printing is that particular equipment is sensitive to high frequency things, so you should have a clean earthing system or a functional earthing system. Always the safety with respect to earthing, the purpose of earthing is to ensure that the touch voltages are limited within the permissible limit. IEC gives a permissible limit. You can see here on the x-axis the time, and on the y-axis you can see the voltage. Say for example, in 100 milliseconds the voltage has to be limited to less than 700 volt, maybe 650 volt, and in 1 second it has to be something about 100 volt, little bit more than 100 volt, and in 10 seconds it has to be less than 65 volt. And whereas the permissible touch voltage followed in IEEE is a little bit different, but there is nothing to worry about it. Basically, the both are safe. IEC is more stringent. So to achieve to follow the curve of IEC, it is a little bit more, we have to make a much more perfect installation. So basically the earthing is always to protect people, and here the target is to achieve the step touch voltage lesser than the tolerable limit. Now earthing, people always ask, do we earth lightning protection separately? No. One building shall have only one earthing. Say for example, in this particular building, I have shown here, there is a air termination mesh. Imagine this is a building, air termination mesh at the top, then you have the down conductor, and then at the bottom, the down conductor is connected to MET. MET stands for the main earth terminal, nothing but the earth bus bar of that particular building. The earth bus bar of the whole building is MET. It is very much necessary that the down conductor and the MET has to be equipotentially bonded. There shall be a direct connection, or there can be a connection through a spar gap. This connection is mandatory, whereas most of the places where I am seeing this connection is absolutely missing. The new method of earthing is called as a global earthing system. What do we mean by global earthing system? Global earthing system, an earthing system created by interconnection of local earthing system to minimize dangerous touch voltage. So basically, the earthing system of low voltage, extra low voltage, and high voltage systems in a typical area, all are interconnected in such a way that there is no touch voltage, or touch voltage doesn't exist. This is called as global earthing system. Global earthing system can be used in substations surrounded by buildings with foundation earth electrical earthing system interconnected by low voltage protective earth conductors, substation feeding densely populated areas, substation feeding suburban area, with many disturbed earth electrodes interconnected by low voltage protective conductors, substation with given number of nearby substations. This global earthing system will not work for an isolated thing. This is if you are in a city center, so a lot of steel or metal installations are there, then we can go for global earthing system, and this is the one which is recommended in industrial system. Now I will skip this. There are the concepts of how high voltage and low voltage. There are two concepts. Basically, low voltage supply confined within the high voltage substation, their interconnection is mandatory. If a low substation, there two chances are there: interconnection and separate. Interconnection and separate means the low voltage earthing and the high voltage earthing you can interconnect, or you can separate under certain conditions. Say for example, here the picture what I am showing is there is a transformer. You have the high voltage side, you have the low voltage side. RE stands for the earthing of the high voltage side, RB stands for the low voltage side. Now these two earthings separate or together. This is actually a technical question where a designer of the installation, he has to think of it, he has to calculate, and he has to apply his mind and do a proper job. Basically, the idea is whatever you are doing, separate or together, the item number 1, U1, the over voltage at the transformer, the over voltage at the installation, and the power frequency fault voltage has to be reduced to less than certain limit. This is the target. So to achieve this target, the first question which is asked is what kind of low voltage system you are using. You are using a TT system, TN system, or IT system. Now what is the tolerable limits and so on. This is the job of the designer. So we can follow both. Actually, I don't want to explain this very much in detail because this itself takes a few hours. So, but I would pinpoint that these three, the purple color, U1, U2 and UF, these are the voltages which you are supposed to take care. Now, one interesting subject which is for the earthing of surge arresters in high voltage. Now, what I am showing is the T stands for a transformer. This is a transformer, and you have the L1 is the line, L2 is the line 2 between the line and the surge arrestor. This is the zinc oxide arrestor, and L3 from the surge arrestor to the earth pit. Maybe the earth pit, everything is interconnected together. This is one way of installation. Basically, this is a poor quality installation. Because of the lead length, basically this wire length, due to the wire length, once when the lightning current flows through this wire length, there is a lot of voltage drop happens in this particular wire length. As a result, the stress which goes into your transformer is very high. So this is actually not the recommended way. The second method recommended in the standard is the earthing part of the zinc oxide varistor, the surge arrestor. It can be connected to the transformer tank. This is an improved way. And the best way of connecting surge arrestor in the high voltage substation is this way. This is the one which is recommended in the standard. You know, this you can take as a guidance, but generally whatever we are seeing, especially in the distribution transformers, this is the one. The poor quality installations are carried out across India, and sometimes the lead length of the earth wire is sometimes 10-15 meters. This is absolutely wrong. Once when the line length is more and more, the effect of the surge arrestor is gone. You will have more voltages into your building. Now going back to the regulations of India. In 1937, we had the electricity rule, which has been formulated as the Indian electricity rule in 1956. And in 2010, the measures relating to safety and electricity regulation 2010 came into Regulation 40. Regulation 40 is a testing of an installation, insulation resistance test. So in the regulation, only insulation resistance test is shown, whereas in the IEC standard, which I have shown just now, there are 16 different verifications and there are about 10 different testings. So as a result, what we use is mandatorily, we are doing only the insulation resistance test and the earth pit resistance test. Unfortunately, the second one, earth pit resistance test, it has nothing to do with safety for in low voltage system. Now, the practice which we follow is always across India, 2 for neutral, 2 for body. Why I put 2 for neutral, 2 for body is transformer neutral, 2 separate and distinct connection to earth pit. Transformer body, 2 separate and distinct connection to earth pit. Generator, separate. Actually, these are misinterpretations. It is not written in the regulation or in the standard, but somehow we started reading the regulation in this fashion. I have the example, I will explain you in the next slide. Then, safety audits. Wherever we do industrial safety audit, industrial or commercial safety audit, the more concentrated subject in the safety audit is about sometime insulation resistance test, and the most common concentration is given to the earth pit resistance test. And safety audits are always concentrated towards what kind of PPEs are used, what kind of charts are there, what kind of boards are there. There are even reports, safety audit report, where I have seen the size of the danger board is smaller, so the size of the danger board is smaller. As a result, you lose complete safety. This is actually, these are not the important factors. The basic test which I have shown, these are the most important. So PPEs, charts, boards and other things, these are one line. Everybody should follow it, that's it. And nowadays in industry, thermography and arc flash analysis are done. Actually, thermography and arc flash analysis, it is an extra safety measure. You do the basic safety measure properly. Once when your basic safety is ensured, then you do these measures extra. That means the 10 different tests and the 16 the inspection points. After doing the test and the other thing, the inspection, we are supposed to do. If the customer have money and if you wanted to have further safety, you can go for a thermography and the arc flash study. But the basic important subject is the fundamental safety measures are always missing in this list. So more than that, so far I have not seen any safety audit more than this, especially the leakage test, that means the insulation resistance test, the earth pit resistance test, PPEs, charts and boards, thermography and arc flash. More than that, the test which is mentioned in the IEC is mostly, I am yet to see a building in India which is tested as per the IEC 60364. I repeat, I am yet to see a building which is tested as per IEC 60364. This is very important because I am coming to the next slide. Misinterpretation of the standard. So this 2 for neutral, 2 for body, 2 for distribution board, 2 for lift, 2 for UPS, 2 for almost every electrical apparatus. This is one of the biggest misinterpreted subject in India. There is nothing like 2 for neutral, 2 for body. I have a picture I will show you in the next slide. So there are high-rise buildings, especially office complexes and even data centers in India. Data center in India having 100 to 300 earth pits all around the building. Actually, one building requires only one earth pit. And why do we have 300 earth pit? Actually, by installing more and more earth pit, the problems are becoming higher and higher. And then we have the habit of using chemical earth pit, digital earth pit, pipe-in-pipe earth pit, and so many most modern names which we call these earth pits. And some of the earth pit vendors, they even say that I have a chemical and my chemical will absorb the short circuit current. My chemical will absorb lightning current. Actually, all these claims are wrong. IS 3043, neither the standard nor the regulation has written in this fashion. So this is a misconcept. Let us just find out what is written in the regulation. Regulation number 41. 41 subclause number 1 talks about a neutral conductor. This regulation says that the middle conductor of a two-phase three shall be earthed by not less than 2 separate and distinct connections with a minimum of 2 different earth electrodes. Yes, of course, the regulation says you should connect it to 2 separate and distinct connection to 2 separate earth electrodes. But what? You should read here, neutral conductor. It is not the neutral terminal of a transformer. It is for a neutral conductor. Where this is applicable? Where do you run a normal long neutral conductor? A neutral conductor is running long for public distribution. So in a public distribution, the fourth wire, which is called as combined neutral and earth conductor, that conductor is earthed on the post, overhead line on the post. The neutral conductor is connected to earth pit, maybe 2 numbers of earth pit at every maybe 3 times every kilometer or something like that. This is the meaning of the particular regulation. This has nothing to do with the terminal of a transformer or a DG. Then the next one, neutral point of every generator and transformer shall be earthed by connecting it to the earthing system by not less than 2 separate and distinct connections. Please understand, this is earthing system. It is not an earthing electrode. Earthing system consists of earth bus bar, an earth conductor, equipotential bonding conductor, earth electrode. So earthing system is a combination of several things. So basically what I wanted to tell you is the regulation never has written that a transformer neutral has to be connected to earth electrode in soil separate, transformer body separate, 2 numbers. This is never written in the standard and it's wrong. Here, one of the problem which I see is whenever we listen to the word earth or earthing, then immediately people think that earth means the earth electrode in soil. Actually, earthing and earthing has nothing to do with or very little to do with earth electrode in soil. I show you the picture from IS 3043. The manual changeover of a DG and the electric supply. What you should understand is the electric supply considered here is a TMCS system. First is you have the earthing bus bar. What I am showing in the picture is the correct way of earthing in a typical building. You have the earthing bus bar, transfer the DG body and the neutral, the body, the alternator and the engine connected to the earth bus bar. The neutral is connected to the earth bus bar. Incoming electricity board supply, the PE conductor, the protective earth conductor is also connected to the earthing bar. Now the load side PE conductor, protective earth conductor is connected to the earthing bar. And now you see this extraneous conductive part. Say for example, you have a lightning protection system. The lightning protection system down conductor is running just outside the building. So the same bus bar also should be connected to the down conductor system of the lightning protection system. This also shall be connected to the each and every metallic installation in the building, such as metallic pipe, metallic water pipe, gas pipe, or whatever the metallic things are there, and the metallic rebar of the building, the steel reinforcement of the building, and if you have an industrial building, the steel structure of the building, and those are called as extraneous conductive parts. So a connection from MET to the extraneous conductive part is also mandatory. And now the earth bus bar is also connected to the independent earth electrode. And now you should look at the symbol of this particular earthing. It is not to earth pit. This is a chassis earth. So the meaning is little bit different. I will explain this, the chassis earth, maybe, it need a lot of time to explain. Today we have a short time. I am already 15 minutes over. I thought of finishing in 40 minutes. So I go a little bit faster. So this particular picture is available in IS3043. You can download the IS3043. Now almost all the BS IS standards are available at free of charge. So you can download it and you can look at the picture. Now, the most important subject here is not the earthing. The most important subject is what kind of system you are following. Are you following TNC, TNS, TNCS, TT or IT? Unfortunately, if I ask this question to a practicing electrical engineer, then the confusion starts. People say, I follow TT, I follow TNS, but here this is a big confusing subject. Now, as I showed you, the uniform international standards for low voltage safety, the IEC 60364. Worldwide, all the countries follow the same rules stipulated by IEC 60364. In India, we have the equivalent, which is called as IS 732, Code of Practice for Electrical Wiring. In 1989 itself, not today, 31 years back, the Bureau of Indian Standards adopted the standard IEC 60364, and it has been made as Code of Practice for Electrical Wiring. Lot of engineers know the code number, but what is written in the code is not followed very well. Instead of following our standard, what we do is there are, if we look at the tenders published in the public domain, some tenders ask for a design based on the NFPA, American style. Some people ask for, or some people follow the British style. Some people follow the German style, but nobody follow the Indian style. There is an Indian standard which is equal to these particular standards, and the standard is available free. We don't download it, we don't read it. And now what is written in 1989, inspection and testing, there are the tests which I have shown in the IEC standard. It is written 31 years back in India, but even today nobody follow this. As I said, I am yet to see a building which is tested as per IS 732. 31 years past, this standard is published, and now the most important point is an installation tested as per this particular standard, not the new one, the 1989 standard. An installation tested as per 1989 standard, 90% of ignition of fire from electricity can be avoided. So the fire department, because in case of fire, the most affected people are the fire and rescue department of the state governments. The fire and rescue department, they can make an immediate solution. The fire and rescue department, if they make a regulation or if they make a rule saying that we will not give you fire approval if this test is not carried out. So simply make a circular and ensure that every installation, especially the large ones like high-rise buildings and industries, are tested as per this IS 732. Your 90% of ignition of fire from short circuit can be avoided. Why? Because if the building is tested properly as per IS 732, all the problems which is going to come in future will be found out and we can rectify it very well. But instead of following this particular system, the complete installation concept, what we do, we always say that the electrical safety, let us put a wire, a good quality wire. Instead of FR wire, let us put FRLS wire. So by putting FRLS wire, I get safety. Somebody says, no, you install an RCD, you get safety. Somebody says you make a special circuit breaker, you get safety. Somebody says you put 5 more earth pits, you get the safety. Actually, safety has nothing to do with these components. Safety has something to do with the whole installation. Your installation should follow the basic safety rules. As I said, if I ask an engineer, what kind of network are you following? Are you following TT system, TNS system, TNCS system? There the confusion starts. Product manufacturers often use the electrical safety as a marketing tool. Say, for example, a manufacturer with a new wire, he will say, electrical safety, I have a new wire, and by using my new wire, you achieve a high degree of safety. This is not exactly correct. You go to the websites of any British company, you type BS7671 and you find out, you can get the details and you can find out how safely, how beautifully they are following the standard. Electrical safety in Britain means BS7671. It has nothing to do with the wires and the breakers and other things, because the regulation very clearly has written where to use and what to use. So I would like to slowly go towards the conclusion part. The major reason for the accidents in India is understanding of standards and regulations, and its applicability is a little bit a problem. Misinterpretations are again a problem. Missing concepts of electrical safety, especially in design, erection and verification. As I told, verification is missing. And the last one, non-usage and availability of products meeting these standards, poor quality products. So my recommendation is don't use the national standards of Britain or America or German or national French or whatever. Use only IS or IEC standards. It's very clear, because we are Indians, we have the national standard. Our national standards are adopted from IEC. If we don't have an IS standard, go for the IEC standard, very easy. Then electrical safety require a good installation. Good installation in the sense, it starts with the transformer, secondary terminal and up to the final socket, consisting of several electrical components. But the whole story is how are you making the whole installation. Now, I have put everyone is responsible for the improvement. So, say for example, CEA regulation, at the moment the regulation 40 says every installation you should do the insulation resistance test. That's not enough. There are different tests. The ideal situation is if the CEA regulation 40 says installation up to 1000 volt AC and 1500 volt DC shall be designed, directed and tested as per IS 732. One line will do the job. But here the problems. We have the habit of following 650 volt from the old British system, but 650 has been thrown away by the other authorities, other countries. Now low voltage means up to 1000 volt AC or 1500 volt DC. So first we should change our concept of low voltage. Then we should change, instead of writing a big regulation, write one line. It will do the job, because IEC, I put IEC 732, it's IS 732. IS 732 will do the job. Then the second one, fire department. What they can do is include the testing as per IS 732 for critical buildings. Very simple. One line. This is what is followed across European nations and some countries in Asia, such as Singapore, Middle East, Hong Kong, Japan, and so on, even in Sri Lanka. Now, insurance companies, they can take a stand that any installation which is not fulfilling the demands of IS or IEC standard, they are unfit for compensation in case of an accident. If these three points are made clear, then you can be very much sure that definitely the installation quality will increase. Now the last one, knowledge and training. As I said, we have conducted a lot of trainings, continuously we are doing training. Now, during the last webinar, we got a question. The question is, you are making short time classes like 2 hours, 3 hours, but this only looks like an introduction of the course. As a result, now we started doing 3 different training classes. The first one is design requirement in low voltage system. It's a 2 hours course, 2 hours per day, 3 days per week and 8 weeks, so 48 hours. Verification of LV system. This is for the inspectors, say for example, 2 hours per day. And again 48 hours, and for safety auditors 36 hours training class. This is what we are doing. We started doing it, and we got a lot of response. So by this I would like to conclude my presentation. Maybe we as a lot of people ask, what kind of business are you doing? Yes, we are into the business of our business is double insulated boxes, the electrical installations such as junction boxes, distribution boards and so on. We are also into lightning protection and earthing and SPTs. This is what we do with respect to the business. By this I would like to stop, and we go for the question answer session. Over to Patnaik ji.
Sure. Namaskar once again, and it is one of the real informative session, and a lot of things actually you listened from Gopakumar, and particularly I am exactly to remind you once again, the things what you have all listened, it is of LV voltage. So I'm not going to tell that what is exactly the limitation of the LV voltage, but you have to keep it in mind, the one which you are using in the grid substations and which you are using in our normal distribution stations. The earthing system, the practices and all these things are slightly different. Of course, we will come in details of that one whenever the questions to come out, we will be coming to that one. So let's to go for the fundamental question some participants have asked. In the practice of taking this fundamental one, let me to come this one which is of a very simple way. Gopalji, actually, is there any major difference between earth and ground? One gentleman has asked.
Sir, this is the term earth and ground. Earthing is used actually historically. The word earthing or the term earthing is used in European countries, and the term grounding is used in America, especially the IEEE, NFPA, and all. They were using grounding. So historically, they still follow. America follows grounding, and the Europe and IEC follows earthing. Basically, both are the same. The terms are the same.
Yeah. Terminology wise, it is same, but sometimes some books also they basically do so say that grounding is relating to the system like our electrical system, where suppose on three-phase fourth wire is there, the neutral one, it is need to be connected. That basically some literature they say also it is grounding. Whereas if it is going for like equipment or metal body or non-current carrying conductor part, it is connecting to the ground. That basically they say it as earthing. This is of course both way say it as earthing. This is of course both way the things are same. Finally, it is being considering to the safety of equipment one way, another is safety of the human being. One more question. It has come, what should be the safe distance to be maintained to have the transformer or LT cable or ST cable in case of petrol pumps?
Yeah. Sir, the first question, say for example, earthing of a transformer is called as a system earthing. In our terminology, it is system earthing, whereas in America they call us a system grounding, and the equipment side is called as equipment earthing or equipment grounding. So basically, if we look at the word earthing, there are several things. A protective earth conductor is used in IEC, protective grounding conductor is used in IEEE and in the Americas. So protective bonding is written in America, protective earthing is done in Europe. So basically these two are different, but under this earthing or grounding there are several sub clauses. We should look what is earthing, what is equipment earthing, what is equipotential bonding, and so on. Now to the second question, sir, the question was not very clear. What was the question, sir? What is the distance between?
Yeah, question was that as for the installation of all our EST equipments like transformer, ST cable, LT cables and all, what should be the minimum distance you have to maintain as far the petrol pumps are concerned?
Yeah. The distance between, the physical distance between the transformer and the petrol pump, I am not sure.
Yeah.
Definitely no one will put a transformer inside the petrol pump. But if the transformer is even, mostly these transformers are of small size, the distribution transformers. Even if it is just outside the petrol pump, nothing happens. But for petrol pumps, the recommended method is a TT system.
Yes, exactly. Talking about the petrol pump earthing and all, you told of it is of TT system. As for the kind of all electrical items, gadgets, what we are using, those are of EST or HV equipments and all. There is, of course, there is no any guideline. I mean, what exactly to be maintained all. And another point in your presentation slide, we found also, and all participants must be interested to listen about it. something you explained that earthed system and unearthed system. So earth system and unearthed system, and considering that one in the electrical sense of delta winding and star winding, and one more is of a star winding with star winding. I mean to say, whenever it is of delta winding, automatically the things will be considered as of system is concerned. It will not be any earthing system. It will be unearthed system. So do you mean that the unearthed system means the this medical system or the limited system you told? Should we go there the delta winding?
No, sir. In both the cases, the earthed system can be done in delta or star. In case of a delta system, one of the phase conductor is earthed. Whereas in an unearthed system also can be made with either a star or a delta. Basically, the current carrying conductors are completely insulated. Current carrying conductors, in case of a delta connection, the three phases. In case of a star transformer, three phase and the neutral conductor, the star point. These four conductors in a delta connector transformer, it is completely insulated. It is not touching anywhere. It is intentionally not earthed. So the meaning of unearthed system is the current carrying conductors are not earthed. Earthed system means for example, you have a transformer or an isolation transformer with the secondary side star connection. The star point is earthed. So what we are achieving by earthing is the voltage, the system will get a reference. So the voltage is made stable by earthing. So the neutral earthing, what we are going to achieve is the voltage of that particular system is stable. So as a result, the insulation can be limited, over voltages can be controlled, and so on. So both star or delta, both the earthed or unearthed system can be used.
Yeah, actually, if I am just do speak in this one in a particular concept, then I can say as per the star connection is there, the common point, the neutral point, or the common point that needs to be connected to ground. And one advantage will be there, as Gopakumar told, कि the system does not need of higher insulations, because we are exactly binding that neutral, so it will not be getting any chance of over voltage development during the time of fault occurrence. Suppose it happens to be any kind of unearthed system, the system is not connected to ground and it will call the floating neutral, then if any kind of fault occurs, then automatically the voltage will be becoming more on the neutral. So it may result that insulations we need little bit more. And if I am correct, the one which he has explained, that medical system, the one where it is happens to be, anything you are doing on earth system means you have to take care of the insulations. So if you will be taking insulations on the first attempt, it will be giving you one indications that something has happened in as per the first earthing system is concerned, but it will allow for you to continue for the supply system. Whereas you will be busy of finding out that particular one where earth happens. Suppose in first earthing system, one more earth it resulted, it will become short circuit. So we must be listening from Gopakumar, the medical system. Suppose first earth has happened and continuation of supply is there. During that moment, before tracing out the first earth, again one more earth resulted, means short circuit resulted. So how to address it?
Yeah. Sir, in an IT system, especially I will share the screen again to that particular slide. I'm sure that is a very interesting part. Yeah. So here the earthed system and unearthed system. In an earthed system, safety is achieved by automatic disconnection of supply. That means the supply should trip as quick as possible. Whereas in case of the unearthed system, safety is achieved by protective equipotential bonding and monitoring of insulation during first fault. Monitoring of insulation is done by insulation monitoring devices. So there is a device called the insulation monitoring device. You should connect this device between all the current carrying conductors and the earth. Earth means the metallic parts of that particular building. So as a result, whenever there is an insulation failure, this device will give you an alarm. Basically, you can set the insulation. Let us say at the starting of the day, the insulation is 10 megohm. You put a limit. Once when the insulation is less than 2 megohm, because the insulation over a period of time, it keep on reducing, it keep on degrading, and you can set the limit. Once when the insulation reaches certain limit, the device will give you an indication. Maybe either it will give an alarm or it gives some indication so that you can take care of the system. And even in case of a dead fault, the first fault, one of the current carrying conductor is connected to the earth. Earth means the metallic object of that area. Nothing happens. So there is no shock, there is no hazard. But during double fault, the second fault, of course, the system should disconnect. Continuity of supply is for the first fault. Disconnection must happen in the second fault. For that particular disconnection, we have to use devices such as MCBs, RCDs, and so on.
Yeah, good. Actually, that is one of the very dangerous part also. If in case of first one not exactly locating the fault and the second one comes, then quantum of current will be very severe, because the kind of things, and it has to go for tripping. Fine. And one more question from fire gentleman has asked, I think so. Is there any statistics on a number of fire accidents that are attributed due to electrical wiring? Any statistics is there?
Yeah, this is a very interesting part because I have no data. The data available is only from the fire authorities of different states. Say, for example, after a fire, I think last year in Bombay, the fire authority, they made a statement, 50% of the fire accidents in Bombay are due to short circuit. And maybe in another city, they say 70% of the short circuit or fire are ignited from electricity. Another city says maybe 20% are due to electricity. But as a whole, there is no concrete data available. But if we look at it from the safety point of view, if we look at the quality of installation and the following the rules and regulations, I would say any building, any time, this danger can come. So I accept that maybe probably 50%, 60% of the fire in buildings are due to electrical reason. Because imagine about 2 months back there was a fire accident. I was there in the site just before the COVID situation. It was a warehouse. Nothing was there inside the building except electricity. There was nothing. There is no movement of people. There was nothing except electricity, and suddenly it got fire. So nobody is there going there to put the fire. So the only reason is electricity. So if we analyze a lot of things, the fire is the main reason, not only in India, globally.
Yeah, of course. So what is the permissible step and touch potential for various voltage level? Also, please share the standards to refer. Yeah, good. Yeah, it is already been explained also. Please.
Yeah. This is standard for any voltage, be it low voltage, high voltage, extra high voltage, or whatever. This is the maximum permissible touch voltage applicable for a human being. A human being shall not be exposed to a voltage more than this, because then the person will get a shock and it's a dangerous situation. So this is so the earthing system, say for example bonding, interconnection of different items in a substation. The bonding shall be made in such a way that the lead length has to be as minimum as possible. As a result, the touch voltages during a fault is limited.
Yes, absolutely correct. Actually, one more point Mr. Lalit Prajapati has asked. Shall we use standard earthing for copper belt area particularly, as we are having more lightning and damaging, the equipments are getting damaged because of so. Standard earthing is there for copper belt area?
Copper belt area means the mines, I believe. Copper, maybe probably the mines area. Lightning protection, there are two different subjects. One is external protection, next one is internal protection. In fact, lightning protection is the most interesting subject for me. External protection, internal protection. External protection means protecting a building or a structure. So here what I am showing, in this particular picture, the red one is nothing but the air termination mesh at the top, the down conductors, and the earthing. So here earthing. For explosive areas and areas wherever sensitive things are there, we are not supposed to make the independent or separate vertical rods. We are supposed to make a ring earth. Ring earth means a conductor all around the building as a ring. So Basically, external lightning protection is for protecting a building from a direct lightning strike. So you need to have an air termination, down conductor and earthing. Then the second part, electrical and electronic equipment plus the human being inside the building. So electrical and electronic equipment in the installation is protected by making equipotential bonding. Equipotential bonding in the sense it is a protective equipotential bonding. There is main protective equipotential bonding, supplementary equipotential bonding, and you are supposed to have surge protection devices called as SPDs. So the SPDs has to be installed at different locations in your electrical system so that a very good equipotential bonding is created. Basically, SPDs are used to create equipotential bonding between earth and a live conductor, a current carrying conductor. So if you have external protection, your building is protected. If you have an equipotential bonding system with SPD, your equipment are protected. The next subject is, of course, shielding of the wiring. Long wirings, you need to follow certain shielding rules. If you do all the three, your equipment will be definitely protected.
Yeah. Actually, I am also supplementing some of the few points. What it happens whenever we are having this GIS or the compact houses and all, there we are using also the case earthing, contour earthing. Exactly, Gopal Kumar was talking about that one. The case earthing, in the sense, there will be some, high thickness copper kind of things will be there, and that will be just surrounding to the total building, so that the things will be considered as one bonding. So that is the kind of things. And one more question has come. In regulation 81 of CEA, construction of this earthing, independent earthing is specified for surge arrestor. So how to go for exactly to speak this one? Anything related to that regulations, please justify that particular point.
Sir, as I remember, it is not regulation 83, it is 73.
It has been mentioned that 81, George CP, he has mentioned.
Yeah, I think it is 73. What it says is that the lightning arrestor, the surge arrestor has to have a separate connection, and the connection shall not pass through metal conduits, metal pipes and all, and it should go to a separate earth pit. My simple answer is that is not the right way. So that is this is what I am showing in the picture, in the presentation. This picture is exactly from the IS standard or the IEC standard. It very clearly had written, say for example, the method here, the first one, this is what we follow. The earthing bus bar of the surge arrestor, 3 surge arresters connected together to an earthing bus bar, and the earthing from the earthing bus bar. The earthing bus bar is insulated, of course, and then it is
I'm just interrupting you, but the kind of things which you have shown, that is not his question. Question is being shown, the one which you have shown here, it is been seen that one independent earthing is there. So he basically mean to say, I think the high voltage part, I mean the kind of high voltage side wherever we use this lightning arrestor. So whether that particular independent earth should be independently kept or to be connected to mat. This is I think what he basically means to ask from you.
Yeah, it has to be connected to the mat with the shortest wire length. The shortest wire length. And the best one is something which is there on the central picture.
Yes. So this is something, why can't SCBs insist for the following electricity safety standards in case of high-rise buildings? He means to say that SCBs and regulators should have the control. They should not go for energization of the building. So these standards, what you are talking about, why it is not becoming mandatory for everyone, so that the people will not get the supply? Can you actually? It is of course not a technical subject. It is a question of deliberation, but still some viewpoints we want from you.
This is actually, it's very difficult to answer. One of the main reason what I understood is actually no one is purposely doing it. It's because of unawareness. It's because of our negligence. So mostly, our habit is if we have a live conductor, that's it. So we want electricity. We are not bothered about safety from that wire.
Exactly. And also that time people, those are of that way preparing these real estate people know, they will be pressing hard for God to get the connections, because everything goes in that line. Anyway, that is a different way to discuss. And one more question has come already. It has been asked. It has been described also. Why in distribution transformer like 25 kVA? two chemical or two rod of or pipe earthing are given. Is it important?
Actually, I have to ask the question to the user, back to the user. Nowhere it is written, and then why do you do it? You don't need to do it.
Okay. So there is another question has come in general. RYB phase electricity common ground is sufficient in load side. This is the way. They are asking that is it sufficient that the common earthing to be taken on the load side? That is one question. Second way, for single phase and three phase neutral, grounding can be sought to achieve less than 2 volt neutral to ground. So in either home or industrial applications, this particular 2 volt practices with of neutral to ground, where it is to be correct, whether it is for home applications or the industrial applications they wanted to listen. So this is that. And another one he has asked, EB and the UPS, can it be connected to the same earthing? These are the three questions are there.
Okay. So what is the first one was, what was that, sir? The three-phase system, common earthing.
Yes. Single phase and three phase neutral. Should it be neutral and grounding? Can we just make it a common earthing?
Yes,
this
of
is
course.
The first question. Yeah.
Yes, of course. One building should have only one earthing.
Yes, correct.
If you have a large building, let us say an industry of 3 kilometers long and 2 kilometers wide, there should be only one earthing for that building. So one building, one earthing. Then the second one. Especially in office complexes and places where there is unbalanced load or single phase load, you will see the neutral current. And sometimes, neutral current, if there is a harmonics, especially if SMPS power supplies are there, then the harmonics will be present, the third and fifth, and maybe the harmonics will be amplifying the neutral current. As a result, your line conductor will be carrying 100 amps, but the neutral current may be 160 amps. As a result, a lot of current flows through the neutral conductor. Now, imagine you have an UPS in one floor and you have the equipment maybe in the second floor. The wire length is, let us say, 100 meters. And once when the current flows through this 100 meters, there is a voltage drop on the neutral conductor. And that voltage drop will be experienced. Say, for example, you have a UPS in the third floor, you have the equipment in the fifth floor. Once when you measure the voltage between the neutral conductor and the local earthing there, that means maybe the equipment body or whatever, you will experience maybe 2 volt, 3 volt, 5 volt, 10 volt, any voltage. So with respect to safety, this voltage can go up to 30 volt, because up to 30 volt, it doesn't make any shock. So up to 30 volt is not a problem for safety. But with respect to the functionality means the signal reference. Say, for example, electronic appliances communicating each other. Every kind of electronic appliance should have the same reference point, and that particular earthing is called as functional earthing. For the purpose of functional earthing, sometimes some manufacturers recommend that the neutral shall be have maximum 1 voltage, neutral conductor 1 voltage, 2 voltage, something like that. Actually, a functional earthing can be made even if the voltage between neutral and earth is, let us say, 10 volt. It is possible. There are clear rules and regulations available, but the problem is situation to situation it varies. One industry in one way, other industry may be in the another way. So basically this subject, what much voltage can have the neutral? I would say maybe 5 volt, 10 volt is also okay for the safety and for the functionality of the equipment. So the question number third is?
Question number third, something related to this one, EB and electric supply and the UPS, the one which are connecting. Should it be having of same earthing or different earthing?
No, same earth.
Yeah. And another question is come, it is actually one of the pertinent question also we should have to discuss, because nowadays we are using the large scale of inverters. And as far the safety is concerned, people, they do not have anything relating to that. Sometimes what it happens, whenever supply is not there, they use their inverters. So by that practices, the supply gets backfed to the the pole itself. So how to address it? What sort of safety precautions you have to attend here?
Yeah, sir, here the big problem is mostly only the phase conductor goes inside and the neutral is common for the inverter and for the electricity EB supply. As a result, once when the line conductor disconnect, actually the backfeed from the inverter supply goes to the distribution 230 volt, and sometimes it gets amplified through the transformer, and even 11 kV also you can see live condition. So the best solution is you should disconnect two pole if it is a single phase inverter. Both the line and the neutral shall be disconnected. At the moment we don't disconnect the neutral, and that is the biggest problem. The neutral also has to be disconnected. It should be made mandatory. Every inverter should follow only this rule. That's it.
Yeah.
But by making it common, they save a little bit of money. And if we ask for a cheaper inverter, of course we get with a common neutral.
Yeah, actually you mean to say that should we use any DPDT switch here?
Yes, of course.
That will be the best solution. Even if that inverter is not having, then we should have to have one DPDT switch, so that the kind of things will be going either to be with inverter or with that one. So the switch will be just getting to separate upon. And one more simple questions I'm asking. Right now, some recommendations are coming in any case of electrical installations, as far protection devices are concerned, we should go for TPN. Instead of a TP, we should go for a TPN. How you will be adding some few, your views regarding it?
Yeah, 3-pole and TPN.
Yeah.
See, sir, here the basic goes to what kind of network we are using. Are we using TNC? TNC stands for Combined Neutral and Protective Earth Conductor, or we use TNS or TT. So, in case of a TNC system, the fourth line, that means the neutral conductor, you are not supposed to disconnect under any condition. So you must use a TP, 3-pole. TPN is not possible. In case if you go for a TNS system, you can go for you can isolate all the four conductors. So the answer to this is what kind of system you are using. Are you using TNC or TNS? So the second answer is, depending upon some of the load and criticality of the load, the switch connection, the method of isolation is also explained in the IS 732. Probably you can look at the chapter 51, IS 732 clause number 5.2. This is explained. Now, another important information which I wanted to tell you is, the IS 732 is from IEC 60364. The original IEC 60364 is costing about 70,000 rupees. Whereas IS 732 is free of charge. You go to the website of Bureau of Indian Standards, you make a username, password, and you can download the standard free of charge. IS 732, IS 3043, National Electrical Code, National Building Code, all the standards are free in IS code. So you can go through the standard and read it, please.
Yeah. Actually, I am also going to supplement a simple point. As per the kind of switches what we are using, its main purpose is of two way. One is for maintenance, and another one is for automated tripping out during the time of fault occurrences. So question of maintenance, whenever it comes, so we need to have the separation of a supply system and separation of the load. So in that practices, if we will be going for mandatory as to use TPN, then automatically this will be just going to separate both of the system, and we can work upon accordingly wherever the things are needed. And as per kind of protections are concerned, same like also. So what I feel, Gopal Kumar, I think we should go for asking, and not exactly the kind of rules, but we should ask them as practice to be used with our TPN. Am I correct, no?
In TNC system, we cannot use a TPN because there are some, again, another the condition is a little bit different. TNC is a system where neutral and protective function is combined. If we use a TPN switch, the P conductor is nothing but the protective earth conductor. Under any condition, we are not supposed to disconnect the protective earth conductor. In a TNC system, if you use a TPN switch, the earth conductor itself is disconnected, which will end up with another kind of trouble.
Yeah, so, and one more question has come relating to this. What about the connecting equipments? It's neutral, functional are things of different voltage grades, say 3.3 kV, 6.6 kV, and something 1 kV, etc. Is it okay to connect everything to MET?
Yeah, this is called as the global earthing system. Of course, you can connect everything to MET. Only thing is, you have to follow. For example, the testing part, the final testing is very, very important. So not one rule, there are several rules. Technically, we can connect everything together, but we need to follow certain testing procedures and designing procedures. If this is followed properly, we can have it, and this is sometimes called as a global earthing system.
Yes, good, very good. Actually, another question has come relating to this during construction site, and we use the temporary kind of electrical connection. So that time it is the need of the way to go for the GI wire to the body earthing and all. So for distribution board, for supply distribution board, welding machines and all. What should be the size of that GI wire? That is a particular question they have asked. And which standard basically it to be referred to go for?
Yeah. If the line conductor is up to 16 square millimeters, the earth conductor also shall be 16 square mm. For example, line conductor is 4 square mm, earth conductor is 4 square mm. Line conductor is 10, earth conductor is 10. Line conductor is 16, earth conductor is 16. Mostly, the same size of the conductor you can use, especially for small things. And more than sizing of the conductor, equally important is it shall be mechanically protected. Otherwise, in a construction site, the problem is, disconnection and other problems will come. So it has to be mechanically protected. But more than that, the best way is you can also protect the installation with a 30 milliampere RCD. At the distribution board, if you have a 30 milliampere RCD, if something happens to the installation, it trips. So safety is achieved by automatic disconnection of supply.
Yeah, correct. So actually one more point also, nowadays some recommendations are coming, and I do recommend also sometimes to go for 3-phase, like 3-phase 4-wire, this one 3.5 core and 4 core kind of cables for 3-phase supply system. And as far the half core is concerned, I basically do recommend that there should not be any kind of 3.5 core cable relating to this harmonics, voltage swellings and all these things, because zero sequence current in the third harmonic, it will be having 3 times current to flow during the fault occurrences and all. So what is your recommendation?
What you answered it and asking me to repeat. So if the load is balanced, of course you don't need a neutral. It depends how much unbalances are there and how much harmonics are there. So very simple. This is a question actually not exactly relating to this one, but he has asked that license relating things. During the time of construction work, the electrical person, what license they require and in which clause of I rule it will come. I think it will not be discussed here. But anyway, for construction site, again, RCCB and RCBO is enough to protect the person. You have already answered. That should be there. So what is the type of inspection to be carried out for class 2 equipment and class 2 equipment and explosive atmosphere? What type of inspection to be carried out? I think also something not related to us. Sir, can we get a calendar of a training? Yes. For you, he is asking especially for your group. Can you get calendar of a training so that person can plan to join and complete the whole module? I think your team can proceed him. And Mr. Digbeja, actually, if you are listening, then I can just tell you just send your mail ID and particularly mentioning that I want the training calendar. Definitely, these people, they will be sending to you in details. And what type of, what is the recommendation distance already? Yes, very good. It's a very interesting question you asked. What is the recommended distance to be maintained from a LT panel to water uses machine like washing machines? LT panel to water machine. More than keeping the distance, first you should have an equipotential bonding. Equipotential bonding in the sense, I don't know whether we have time, but if you have time, I can again share a screen and I will show you what exactly I mean. One moment. The meaning of equipment earthing. One moment. Yeah. So imagine. Now we will have the full screen. Imagine there is a transformer, there is an equipment, and generally what we do is the transformer, neutral and body is separately earthed, and the equipment is separately earthed. And then on the equipment, only on the equipment, what we generally think, okay, there is a fault, what do we do? A person touching the equipment will get a shock. What do we do? So people say earth it. And then generally in industry, what we do is you buy 2-3 earth electrode and connect the equipment to the earth pit, and then think that the fault current goes to earth. As a result, the somebody touching will not get a shock. Even people say that person will not get a shock. This is wrong. Actually, here the earthing has nothing to do with the safety. Now, the problem is the touch voltage. The body of that exposed conductive part of that particular equipment and the place where you are standing, there is a touch voltage existing. As a result, you will get a shock. The earthing is not going to help you. So in order to avoid safety, what is recommended in the standard is earthing of an equipment means something like this. The equipment, which is called as exposed conductive part. Exposed conductive part is connected to an earth bus bar. Extraneous conductive part like metal pipe, the rebar, and all those are connected to a common equipotential bonding bar. And imagine you have a water pipe and you have a electrical panel and you have the washing machine. If equipotential bonding is done, the chance of shock is gone. There is no shock. But if the water is spilling over and if it is creating another problem, this is not a recommended situation. You should keep it in such a way that accidentally water and other splash of water is not going into the electrical system. Otherwise, if you have a perfect equipotential bonding, chance of shock is gone. You are safe.
Yeah, actually, the one which to be emphasized over here, the one point we should have, and that must be also equipotential bonding. Sometimes what happens, the case or the equalization terminal wherever you are standing, if that terminal and the one which is the body, if they are being connected, interconnected, and the person standing over there, current will not flow because same potential to same potential current will not flow. So that is the most important. Keeping up more and more number of earth pit does not make sense. Rather to develop this particular word and to understand this particular word, what is called equipotential bonding. Another very important question it has been asked also, because already in the design we have available also arc fault circuit interrupter. So basically, though it is available, so he says that why it is not getting available in the market, and as far as India is concerned, why the people are not taking this one as practice.
Yeah, AFDD or arc fault protector, arc fault protective device. Basically, in case of say for example, there is a loose contact in the wiring, the current will not flow in the same 50 hertz cycle. There is some distortion, and this particular device will disconnect the supply. But in case of an earth fault, the AFDD will not work. In case of a loose contact, AFDD will work. In case of an overcurrent, I don't think that AFDD will work. So you need all the protective devices. If you have a very good installation, following our standard, say for example, our standards IS 3043, IS 732 say that we are supposed to use a TNS system. In case of a TNS system, and if you have properly rated MCBs, your fundamental safety is done. Even without RCD, we are able to achieve safety. Now, RCD we are using as a main protector. Say, for example, in case of somebody touching a live conductor, the system should disconnect. So, RCD is used as a not as a fault protector, but as a main protector or enhanced protector. AFDD. Worldwide, people started using it only recently. Even the standards are just going to come. I think there is an Indian standard also under work. But very soon, it's time and knowledge. Slowly, people will start using. I think in the upcoming National Electrical Code, this will be included. So maybe 2-3 years, people will start using AFDD. But don't think that by in my presentation, I told we think that by adding a component we get the safety. It is not true. The whole installation shall be perfect. Now by adding more and more components, you increase the safety. But our problem is the basic itself is missing. So This is the answer.
Another simple question has been asked to us. How do I check simply the circuit is overloaded or underloaded? It is a question of only measuring equipment. If you keep, you can be knowing. So that is a simple question. And how useful are thermal cameras, means thermovision practices in terms of preventing maintenance of the building, such as hospitals? And how frequently should you use that thermovision camera for junction boxes or testing of these heating wires and all? So this is a very good question. Actually, they wanted to listen from you, expert.
Yeah. See, I shown you the 10 different testings in the IS 732 or the international standard, which is followed everywhere, all over the country, all over the world. The first testing is called as continuity of conductor. Continuity of conductor is nothing but the resistance of the conductor which is used in a wiring, especially the final circuit. Now, imagine you have 100 small switch boxes. Taking a thermal camera and taking a photo every time is a tough job. Actually, you don't need it. Even thermal camera, under what condition you are working? Is it working in full load? Then you have to have a load and you have to have a lot of things. But the simple and the most efficient testing here is the continuity resistance of the conductor. Say, for example, you have a 2.5 square mm wire, line conductor 23 meters, and you have neutral again 23 meters of 2.5 square mm wire. You should measure the resistance of this conductor, and then the IC gives you a reference value. And if the resistance is lesser than the reference value, you are 100% sure that your wiring is good. So if there is a loose conductor, then you immediately know it. Simple tests are
fantastic. There. Good. Actually, and one more thing's been mentioned as far as the shielding wire is concerned. The shielding wire of signal wires, should it be earth at both ends, or it will be having of a single point earth?
Yeah, it depends on the system. It depends on, that itself is a big subject. In certain application, only one side you can earth, and in certain application, both side you need to earth. So it depends on the frequencies. Sometimes you need a single point grounding, sometimes you need both the sides.
Yeah. Actually, another very tactfully one gentleman has asked, as you are all talking about that equipotential bonding and all, and finally to be connected to a single point earthing. But he says that the particular single point earthing, do you mean that a particular one electrode and one electrode pit? That is of 1 point. And he is also suggesting if it will be having of one electrode pit and its earth resistance is not good, and if happens to be any problem to that earth electrode, how the system can be managed? This is the question.
Yeah. See, for the purpose of low voltage electricity, please listen carefully. For the purpose of low voltage electricity, if we read our standards carefully, IS 3043, IS 732, if we read it carefully, for the purpose of low voltage electricity, you don't need any earth pit. Especially in a house, in an installation, you don't need any earth pit. Yes, of course, you need an earth pit at the transformer neutral, because you need to create a neutral earthing. You need to stabilize the voltage. Otherwise, for the installation, you don't need any earth pit. Now, for a house or for an industry with low voltage equipment, earth pit in soil is required only for the purpose of dissipating lightning current to soil. For all the other purposes like safety, like functionality of the equipment, functionality of UPS, functionality of electronics, you actually doesn't need any connection to soil. So simple answer is you need a connection to soil in a low voltage system only for the purpose of dissipating lightning current. Other purposes, it doesn't need any connection to soil. You don't need any earth pit, zero earth pit.
That is of course limited, that if the system earthing what they are sending, that is of a good one. Suppose if in case the system earthing is not of good one, then automatically this will be one issue also, because the kind of things will be of voltage generation will be there, and the neutral will be having certain voltage and all.
Yeah.
How will you address that?
Now, sir, if we carefully read our standard, especially for industrial and commercial installation, IS 3043 is recommending to make a TNS system. TNS system means on one side, let me see whether I have a picture. On one side we have the equipment, and on the other side the transformer, and the other side, one moment, let me take that picture. Yeah. So this is how a TNS system looks like. You have the three phase, you have the neutral is connected to earth, and now on the equipment, the installation here, the installation, that means maybe you have the main switchboard, you have the sub switchboard, you have a large distributed thing, you have so many items there on the installation. For the purpose of fault return, you are using a conductor. This is your earthing. The conductor is your earthing, not the earth pit. The conductor is your earthing, because a fault, the fault current goes through this particular conductor, it goes to the transformer, and as a result, heavy fault current flows and the device is disconnected, the supply is disconnected. Now, for the purpose of reducing the touch voltage here, for example, the equipment and the local place where you are standing, imagine you are standing on the 10th floor of a building. And now why I am saying 10th floor means, because nowadays we have large buildings. Imagine you are standing at the 10th floor and in front of an electrical apparatus. During fault, there is a chance that between your leg and this particular panel board, there can be a touch voltage. Now, in order to reduce the touch voltage, what you should do is the rebar under your leg and the body of the panel board, it has to be connected together. So this is called as protective equipotential bonding. That means between your body, between the place you are standing, that means the rebar of the steel column and the body of the panel board, there is no potential difference. As a result, you are achieving safety. Practically, the earth electrode, you need only one here. And this earth electrode, imagine your transformer is inside the building. Let us say a large industry, nowadays, multi-storied buildings, the transformers are inside the concrete area. In that particular case, you don't need this in the soil. You can connect it to the structural part of the building, but you should follow certain rules. So following those rules, you can do it.
Yeah. So actually, one more related to this TT and TNCS system. One question has been asked: how we can create a small TT system for emergency lighting and fire alarm in flat having TNCS system?
Yeah, you have to have an isolation transformer. You have to isolate the supply with an isolation transformer. A secondary side of the isolation transformer, you can make a TT, but in a flat, it's not possible. Because again, flat, the equipment, where do you connect? You have to run a conductor from the building up to the soil. This is very difficult.
So in household, floating neutral is common, so that what should be done for safety of the equipment and human?
Sir, I don't know, install a disconnection. There is a yes. the voltage, over voltage relays, and you have to disconnect the supply. That is the only way. But again, if we go as per the clause 4 of IS 3043, I don't know whether you have read the clause 4. Clause 4 of IS 3043 is explaining about the mandatory requirement of earthing. I remember, I don't remember the exact wording. It is like the legal requirement of earthing for an utility company. So for that particular system, what is written in the IS 3043 is, one moment, let me see. Yeah, I will just show a slide. Actually, yeah. Now, what is written in the standard is to go for a TNCS system with here the transformer, neutral is earth. This conductor is called as combined neutral and protective earth conductor, the PEN conductor or CEN conductor. This particular conductor, once when it flows, once when on the post, maybe every kilometer 3 or 5 times, you are supposed to make this particular earthing, and this is the connection. Regulation 41, clause number 1 explains the neutral conductor shall be earthed by 2 separate and distinct connections. This is the one. So on the distribution, you do this, and at the house, at the building, actually the meaning of this particular earthing, this has nothing to do with earth electrode in soil, but this is the protective equipotential bonding. That means at the meter board, every metallic installation of that particular building has to be interconnected together. Now, in this kind of a situation, even if the neutral disconnects at this place, let us say where the mouse is, if the neutral disconnects at this place, you don't need to worry because the neutral is connected to earth. over voltage or the extra voltage coming on the between the neutral and the earth, it is controlled. So this explanation you can see in the class 4 of IS 3043.
Exactly. That means we are having a redundant earth. Suppose in case of any disconnection it happens, then also that particular redundant earth can take care of it, and also the equipotential bonding as it is being taken at the working area. So the quantum of current also will not flow in advantage connection of a metal body to the live conductor to the metal body. Another question must be going very quickly to this one. New distribution transformer we are using also the arcing horn and all. The lighting horn, arcing horn, and all. It should be connected to earth also. If it be so, then how we will do so?
Sir, actually, the earth here is the structure. You have you are connecting the arcing horn. One side you are connecting to the live conductor, and the second it has to go to the structure itself. The best way is to structure, and in addition, maybe you can put a conductor. But interconnecting the structure and the arcing horn, the earth part.
Yes, actually, is there any standard we are using to go for our household earth fit? Some gentleman has asked.
No, I don't know.
Exactly the general kind of things what earth fit we are using, you must have to use so.
Yeah. Now, sir, here there is a interesting subject. Say, for example, I think regulation 16 or 17. I don't remember which one. 16 or 17 in the CA regulation. It explains about the earthed terminal in a consumer premise. Earthed terminal means actually in the picture. I don't know whether the screen is shared. The earthed terminal means the utility is supposed to provide. I'm sure you can see this picture. The utility is supposed to provide this terminal. This is the earthed terminal. Why this is called as the earthed terminal? Because this terminal is earthed through the conductor, through the PEN conductor, and finally, this is earth. This is the earth of the circuit. The place where the neutral is connected to the earth, this is the earth of the circuit, and earthed terminal means the exposed conductive part of the building, there is a provision for the fault current to return back to the earth, and this is the earthed terminal. It has actually nothing to do with the pit in soil.
Yes. And one more gentleman has asked related to the regulation number 31, related to the test report. Can we please suggest or ask CEA to add number of tests required to be done for LT consumer? This is the one request from his side, as you are already involved with different way. So can you just recommend also to add the number of tests required to be done for LT consumer?
Sir, actually, in our socialist situation, we are, rules are made by the people, for the people, by the people. So instead of me writing, every Indian citizen have the right to, make an opinion about a regulation or a rule to the authority. The best way is, if you can, everybody can write to the Central Electricity Authority, especially if you go to the CEA website, you have to look for the wing power system, and under power system, you can see electrical inspectorate wing. So you go to the electrical inspectorate wing, you can download all the regulations, and there itself you can download it, read it. If you have any queries, you can write to them. And I am 100% sure that the CEA will go through each and every query, they read it, and then only the regulations are made.
Yes, exactly. Because we do some for, because exactly Gopakumar not the only man, we must be also joining hand to go for changing CEA if you want. Because everything just focusing towards the safety, so definitely CA will take care of it and also will add. And another question comes related of putting the lightning arrestor in the construction site. So where exactly we should keep this lightning arrestor during the time of a construction period? So this is a very interesting questions.
Yeah. If it is number one, providing a lightning arrestor for the people is will not solve the problem, because lightning may not hit the area itself. Maybe the lightning is hitting 20 meters away from the building. The step potential means the ground potential rise during the lightning strike is going to kill people. So step potential rise can be reduced only by making an equipotential bonding surface at the soil, which is very difficult in a construction site. So providing a rod and everybody going under the road during the thunderstorm time is difficult. Better don't work during the thunderstorm time. You know that the cloud, it is cloudy, you move away, you go to a safer place. So in America, they call thunder roars, go indoors.
Exactly. So this another interesting question been asked, and almost all that is related to the lightning, the important subject of yours. Which lightning protection is the best? Something particular wise asked. A height radius through tower, or earth mat and spikes covering complete area, or number 3, installation of EAC type of earthing. The 3 options he has asked for you, and which one is best?
Yeah. See, in all the 3 cases, equipotential bonding is mandatory. Now that you keep aside, you can go for a catenary wire. Catenary wire in the sense, on both sides of the building, you maybe erect 3 towers and you put a wire above the building, so that lightning is going to hit that particular wire. This is actually practically not possible in a building. Maybe for an exposed tank or whatever, you can do this. The second method for a building is, if the building top is flat, you don't need to go for a rod. For the flat surface, you can have a mesh at the top of the building that will do the job. And above the flat roof, let us say you have a building with a flat roof, and above the flat roof you have maybe an air conditioner. Now, if you put a mat and put the air conditioner, then naturally for the lightning, your highest point is the air conditioner. It will go and hit the air conditioner. So to avoid the hitting of the direct lightning into the air conditioner, you need to have a rod, and the rod has to be connected to the mat. So a combination of mat and rod is the best one. Now coming back to the third one, early streamer emission, actually it is banned in India. I'm sure you must have read the National Building Code. We are not supposed to use the early streamer emission device, because in my book I have put 4-page explanation, because even in French the way early streamer emission device, ESC device, is used different. In India, what we think is you have a tall building, 50-meter building, and above the building you put a rod and put a 70 square mm down conductor and connect it to an earth pit, and people believe that the rod will capture the lightning and it will send the lightning current through the 70 square mm wire to the soil. Absolutely, this is not going to happen. So ESC as such, the National Building Code has banned. So let us not talk about ESC. It's not applicable to India. That's it. Very simple.
Yeah. Actually, another simple question been asked also. Exactly, we can go for. He's asking that if we are using only earth fit, what will be the total quantum of current it can manage to flow related to fault current? Only one earth fit. Say let it be of 10 ohm.
Yeah. Now for the fault return path, say for example, I am talking on low voltage. For the fault return path, you are supposed to have a conductor. Current never goes to soil, it goes to the source. Here the source is, let us say you have the transformer and the current has to go back to the source. There, instead of routing it through the earth pit, you take a wire and connect directly to the transformer neutral, your fault current. That conductor has to be sized based on your fault. So the fault current simply goes. Now in a TT system, where the transformer is far away from the building, in order to avoid the cost of the extra conductor, an earth pit is made at the transformer and another earth pit is made at the installation. In that particular case, the most important is not the earth pit, but a 30 milliampere RCD. Every building at the meter board, we are supposed to have a 30 milliampere RCD. It is there written in IS 732. I don't remember the class number. Now, if you have a 30 milliampere RCD, the earth pit resistance can go up to 1666 ohm. This calculation is also there. I think it is table number 14. So you can refer that. So in this particular case, the actual fault current going through, actually you cannot pump, few kiloamperes of fault current through the earth pit. It's never going to happen. It's impossible. Yes, of course, in an extra high voltage substation, that is, the situation is different. Whereas low voltage, this will never happen. So for fault return path, you need to have a conductor.
So I can also supplement this particular one. Basically what happens as far the simple rule of electricity says that wherever the source, if the current starts there, then the current has to return to the source. So from the source and coming return to the source, if there is a good connection, let it be of conductivity connection, then automatically current will come to flow. So earthing is not required. But what happens if the length is high, big? So we cannot physically to go for the conductor to be connected from source to the load. So during that practices, we will be using of earth pit there and earth pit here. And during that point, earth pit should be as low as possible, so that will be developing one conducting path through earth, so that it will be again reaching to the source. That is the particular concept basically to ask. So saying and asking of that one earth pit, what is the quantum of current it can handle, exactly we cannot say so, but it depends upon what is the way of a connection. So another question already been asked, already replied also. Earthing is being sized by load and equipment. What do you mean by single earthing?
Single earthing means equipotential bonding, everything connected together. Actually, we should first understand that earthing has nothing to do with earth pit. Earth pit is also one of the part in the earthing system. Or earthing, the new word is not earthing system, it is called as earthing facility or something like that. Sorry, I forget the name. Now, single earthing means everything, exposed and extraneous conductive parts, or in the other word, simultaneously accessible metallic parts are connected together so that there is no potential difference exist. Everything is at one earth. So this is the meaning. Sir, the question has got one more part. What was the, I don't listen to the second part.
No, it was he was actually just about to ask that earthing to be decided. He was having this particular concept in his mind that earthing should be decided in terms of a load and equipment. The kind of load what you are using, earthing also accordingly to be changed. But that is not so. The one you have applied very correctly.
This is valid. Actually, earthing has to be designed based on the fault current, the expected fault current. That means the size of the load, how much load current is flowing and all. But that is not the earth pit. That is the earth return conductor. The conductor which is taking the protective earth conductor. Very simple. Protective earth conductor means the earth conductor which is going to take the fault current back to the source. It has to be sized based on the capacity, based on the fault current, not the earth pit.
The one which you have told, it will be leading some confusion. Let me to clarify the one very clearly. As far load is concerned, whenever the fault occurred, during that time load has no role, because load gets aside and the kind of connection supposed to be taken one short circuit. If it happens to be short circuit, the supply voltage what you are giving and quantum of current what it result, that is called fault current, that should be sufficient so that the quantity of earth conductor or earth sizing conductor what you are using, that has to take care. That is the meaning. So you mean to say so that na?
Yeah. The fault return path, the earth conductor which is taking the fault current back, that has to be sized based on the expected fault current.
Yeah, this is actually one new question. That's why we will be just closing hereafter. But this is the new question. That's why we are taking up. How the solar panel related these RE and all these windmills and all, it is to be connected safely to the substations, which basically has relating to the frequency, this inverter and all these things. How will take care of it?
Actually, the first answer is what kind of supply you are getting from the transformer to your house. If you have, imagine you have an inverter, please don't earth the inverter. I am not talking about the DC side, I am talking about the AC side. That means the AC side where you are connecting the supply. You are getting three-phase and neutral from the electricity supply, and the electricity supply company already earthed the transformer neutral somewhere in the transformer. That is enough. You please don't earth the neutral of your inverter again at your house. You have to simply connect the inverter to the three-phase, plus the neutral has to be connected to the neutral wire which is coming from the electricity board, and the earthing based on TT or TNS system, you have to make a connection to the earth bus bar.
Yeah, and this will be definitely we'll discuss, because it is basically to the society help and all. Actually, Mr. PPY asked the particular question. During these rainy days, it happens to be kind of leakage current passes in the electric poles and all, and there happens to be number of accidents and death also, electrocutions, fatals. It has happened. So how to avoid it? Because it is one of the big subject, big solution we must have to go for. He basically says that we are getting those accidents. So how to? What is your recommendations?
Yeah. So this is a subject which there is a big fight going on. Say, for example, we are supposed to follow a TNCS system, which I have shown in the picture. The neutral conductor is earthed in the distribution. A TNCS system, I am talking about low voltage. A TNCS system is not followed uniformly. Now, in other countries, what is followed? Say, for example, in UK, because our system basically started from the UK. In UK, they say as the public electricity distribution is either TNS or TNCS. Now, we have to actually read it in coordination with our regulation. What our regulation says is, if a line is passing through a place where a lot of people are there, or if it is passing a road, passing a railway track or whatever, then you are supposed to have a guard wire under the line, so that in case if the line conductor falls down, it is not touching the ground. Maybe it is making a local short circuit, so that the incoming breaker is tripping. Unfortunately, what happens, most of our distribution transformers, the regulation says output side, the utility is supposed to use circuit breakers, properly rated circuit breakers. But how many places properly rated circuit breakers are used? Even fuse carriers are used, and instead of fuse wire, the thick aluminum wires are used. As a result, even if there is a fault, the disconnection is not happening. The fault prolongs for a longer time. Finally, it ends up with the accident. Now, the second part is, designing and installing an automatic disconnection system for a distribution transformer is a tough task. I would recommend, instead of explaining it today, we can have a separate session for that. Because if I make an answer, this will be wrong.
Yeah. And in a hurried manner also to comment upon it, it's not correct. But one point only I can add over here. As far as India or wherever all over world maybe, the high impedance fault in LV system, it is very difficult to manage, because the quantum of current what it passes through the body of human being or body of the living being, that even goes with 100 milliampere could be fatal. So that practices the high impedance fault, how to take care. That is the big issue. And there should be one clear-cut deliberation upon it. Anyway, so I think we have to conclude. We are already of 8 o'clock. And I request also to the organizing team, there are a lot of questions also to whom we could not attend. Definitely, you will be preparing the this answer sheet of all those things and to be distributing them. And as I found on the answer sheet that maximum Spark members are there, if you will be just helping out those answer sheet with me, then also I will be posting in this Spark group. So hope so it is a real way of fantastic kind of things we could able to know, and the difference of all these TNCS, TT and this MT, all these things. It is a very, very interesting kind of things, because as I told you, as far the HV system is concerned, we basically do not bother about the EHV and all kind of things. As far my recommendation is concerned, we must have to go for a particular session once again, and I will be asking also Gopakumar to go for especially the particular agenda relating to these issues kind of things. What is exactly happening, and explaining all those supply systems, TTTS and all these things. Hope so everybody could able to learn out of something, and they can go for take away these materials, and these materials also to be shared to them, the kind of presentation slides and all. Now from this is completion from my side. So over to Deepak. Deepak, are you there?
So one moment from my side. Thank you very much for all the participants from my side. So Deepak, you can conclude and close.
Yeah, thank you everyone for the participation. We have shared you the form for feedback in the question answer column, so you can fill it up, which will be more useful for us for making further presentations. So thank you. we'll end the live event, right? Thank you. Bye.
Okay, so namaskar again. Be safe, be healthy. Thank you.
See you. Bye bye.